Okay, we're back after a short break with Carsten on running Debian Linux at scale. The stage is yours.
Thanks a lot. So as you can see, there's no IRC handle, there's no Debian.org address. I'm an outsider, I'm a user. So my talk is basically in two parts. First part, I'll just do a very quick rundown where I'm coming from, why we're using Debian at scale. And the second part is Thomas asked me to do something about this and talk about what problems I see from the outside, and hopefully we can have some discussion later on. Well, I have to leave at 7, so we'll have to see if that works out. Okay, just quickly, my background, I'm a physicist by training. I was doing ground penetrating radar in Braunschweig, and did then a PhD here in Potsdam, next to Berlin, doing radio pulsar searches, so coming from a data analysis background. At some point, I turned into IT. 2007, I went to Hanover, mostly because science is very hard to have a long-term contract, and this gave me an opportunity to continue working on Linux and doing basically at the seam between IT and science. But there, basically, we have a small team doing everything. You could just name it: network admin, system admin, infrastructure. We do some coding, some DevOps. We write documentation. We advise how people run better, the pipelines better. We do any type of support, any level of support. Basically, we just check off our trades. We do everything, but nothing really drill down. So if you ask me something about Kubernetes down at the bottom, no idea. Linux history, just short since 1996, started with SUSE 4.3, and I think Debian, I've used every release since Potato. Laptop is running Trixie right now, so all fine on that stage. My employer is Max Planck Society, or more particularly the Max Planck Institute for Gravitational Physics. We have 6 departments, 3 in Potsdam and 3 in Hanover. I'm from Hanover, and we have a collaboration with the Leibniz University there. We do everything related to gravity. String theory, numerical simulations, data analysis. We build laser systems, we optimize them. We even have a satellite mission, which is it's LISA, which is supposed to be launched in the mid-2030s to measure gravitational waves from space. And right now we have about 350 people, and we expect to grow by at least another 100 or 150 people over the next few years. If you've followed the news, about almost a decade ago, we discovered a gravitational wave, or since then we have discovered many of those. The first one in 2015, and that led to the Nobel Prize in 2017. You can read all on Wikipedia on that. And 20% is basically, if you're near Hanover at the end of August, we have an open day at Geo600. There's a live gravitational wave detector. You can watch and visit them and get some knowledge about that. Atlas, that's the name of our computer cluster, was founded in 2017 with Bruce Allen as the director. You may remember his name whenever you run SmartCTL. It's in the copyright notice there. Our goal was to create a high-performance throughput computer, high throughput computing cluster. Sorry for the wrong naming there. Data center, which is dedicated for gravitational wave data analysis. Building on the knowledge of past Beowulf clusters, either in Milwaukee by Bruce or in Potsdam by us. And we installed this all in the basement, formerly used for storage, on a fixed amount of annual budget, and basically only 2 FTEs. So basically we had to do everything automatically. We run everything in the infrastructure. We have 4 cooling machines with 1,000 kilowatt or 1 megawatt of power and cooling. We run 2 800 kVA UPS systems, which are a bit visible in the background. It's a 450 square meter data center, order of 100 water-cooled racks, 4,500 height units. and everything is Ethernet. We have no InfiniBand there, well, almost no. And it's still 10G base T, so that's 10 years old now. It was mightily fast 10 years ago, but nowadays you probably go for 100 gigabit or even faster. There should be another slide somewhere. Anyway, so in total we currently run about 1,000 compute nodes, bare metal. At the peak we had about 2,500, but we had to switch most of them off because they were just old and inefficient. Right now we have about 41,000 physical cores. I just asked Condor 340 terabyte of RAM in total. Right now 300 older GPUs up and running. We're about to buy another 800 GPUs this year. If you know the Boeing and distributed computing, we have Einstein at Home, which is our backfill on the cluster that all machines are kept warm all the time because sudden power fluctuations couple really bad with cold water supply. And just one highlight there, in June 2008, we were number 59 of the world in the top 500 list. Nowadays, without, millions of euros poured into GPUs, there's no way to get there. And that was CPU only in that time. We used to have about 1,600 global users. We were in a collaboration with LIGO, Virgo, and Kagra. These are 3 big projects of gravitational waves. Observation and detection. After we went out of this, we have now about 100 mostly local users, which are, 20 are active all the time. As you see, we have a wild mix of languages and environments. What people use could be C, Fortran, R, Ruby, Python, doesn't matter. Sometimes even people run MATLAB as a driver script to just make a loop. Could happen, works, as long as the results work out in the end, all fine. Typical way of operating things is user create an analysis pipeline, could be a single program, 1,000 program, or the same program run 1,000 times, 1,000,000 times with different input data sets. Could be one thing in parallel, could be a set of jobs which depend on each other in kind of DAG fashion. And we use HTCondor for us job scheduling, which used to be packaged in Debian, is now coming back again. Tim Tyson applied to be a Debian maintainer, or is in the process of, so that hopefully that should be there. Because right now we're just using whatever they provide us as a package. Yeah. Admins, what's vitally important for us is everything should be as homogeneous as possible. We buy large batches of machines. Top was 2013 when we bought 2,000 machines of the same kind. 4-core, very simple machines. At that point, we hardly had to pay anything for electricity. Nowadays, you have to go much more into efficiency, power efficiency. So what we do is we create a benchmark suite, get the numbers, and calculate how much work can we get done and for the least cost within 5 years. So TCO5 factors in the investment, support stuff, replacement parts, and electricity. Obviously, we cannot really pin down the numbers, but we make educated guesses. And everything needs to be remotely controllable. So if I'm sitting at home, I definitely want to see every single machine. We need to have remote management capabilities. I can watch the boot setup, everything. Everything is, as I said, is automated. So it takes 30 minutes, literally 30 minutes, when a node is installed, plugged in, powered on. It automatically installs itself via PHY. At least the initial installation and all the configurations are then done by SaltStack. As we talked earlier, Ansible was way too slow for us. And 30 minutes is a good time scale for us. We could go faster if we upgraded the hardware on certain machines, like our internal Debian repo, because yeah, you have the bottlenecks, and you just have to see where the bottlenecks are. And if they're really a hard problem, remove the bottlenecks, otherwise you just live with them. Thomas asked me, why do we use Debian GNU Linux? Good question. Basically, we're just comfortable with it. Both admins come from a Debian background. When we started doing this, the LIGO-Virgo collaboration at that point used strictly Red Hat clones. CentOS, nowadays they're using Scientific Linux or Rocky. And since there was a big software suite being built by LIGO, we wanted to have best of both worlds. We wanted to have our background and wanted to keep it and seen it. And on the other hand, we wanted to introduce a second OS, because otherwise you just tailor everything to a single OS, and if there's a bad mistake in there, you just lose the potential to see the problem is with your program and not with the operating system in the end. And obviously, if you do a Red Hat installation, there are, I don't know, 1,000, 2,000 packages, and if I look at what Debian offers me, it's, I don't know, order of magnitude more. And it's much easier to just apt install it and be done with it. Obviously, we also have some in-house experience of package building, some tooling, backporting stuff, so that all helps. Some problems. Commercial software, commercial entities like to talk to commercial entities, which is a problem with Debian because there's not much of a commercial entity behind it, which I think is still a good thing. But then if you want something like GPFS, which is a high-performance file system, it can only be installed on Red Hat systems. We used to have an Oracle HSM system. That's a tape disk storage system. We looked into Versity's system, and they only support Red Hat or derivatives. And what's currently biting us, we're looking into NVIDIA or AMD accelerators, GPUs. And AMD only offers Ubuntu packages. And those are not, they are tailored to the kernel version within Ubuntu. And I tried multiple times to get them to run on Debian, and I just failed over and over again. So I would love to see a better standing there. I have no idea how that would work. Basically the same bandwagon here. In the past, like some Dell servers 10 years ago or so, they asked us to run a shell script when the problem was there. And the first thing they tested was which operating system this is working on. And Debian was known to the script, and then I got no support data. And the Dell support said, yeah, you must run this script. It doesn't run. Yeah, without these files, we cannot give you support. And then, yeah, it's better nowadays because mostly those data is now generated by the board management controllers, but at that point, really bit us hard. With basically two servers, which we had to reinstall Red Hat on to create the service file and then go back to Debian. Completely weird. Same things like if you have firmware updates, which were supported only by Red Hat systems or DOS. Yeah, means either installing Red Hat to do a firmware upgrade or install DOS, which is weird. Also, nowadays it's better with UEFI-based or Java-based stuff. But still, sometimes we always hit this here and there. For me as a user, DFSG is sometimes a problem. Well, not a problem. Sometimes it's opaque. It's foggy. Sometimes easy. NVIDIA's proprietary drivers, NVIDIA InfiniBand drivers, sure, they're closed source. You cannot ship it. Case closed. No questions asked. Maybe in the non-free stuff, but then it's usually, for us, it's usually too old. But we can use upstream here. Not a big deal. Some things came up last week. I talked with Ole about this today. CFIS.io and the NASA open source agreement. That it's not TFSG, and I don't fully understand why. There's some technicalities there. Yeah, OpenCFS, almost the same thing in source form. No big, probably no, or hopefully not a big deal. It's DKMS, which just strains on installation and build times. I'm not sure why Ubuntu, for example, is able to provide CDDL binary packages. Or they used to, I'm not sure if they're doing that anymore, and combine them with GPL kernel. Yeah, that would be nice to have because it's just taking down, adding time to installation times. Communication is always hard. I think Alex went outside again. What Thomas always said when Buster Backports was moved to archive Debian.org a couple of weeks ago, that hit us at a bad time because we mirror some parts of the Debian repo internally, and that caused a problem when that was moved. It was vanishing from there because rsync. And the big problem there was then the configuration update didn't work anymore because it throws an error because it kind of couldn't find the distro anymore. So some communication would have been nice. Obviously there was, but it didn't reach us. So communication is always hard. As Thomas said, there are too many places where it is, and it's probably always the wrong one. And would be better if it would be kind of tailored, like not on an announcement list, but maybe just on the same list where the discussion about backports has been done. KeePass RC stuff, it's very opinionated. I think the decision to remove features is probably correct, but again, communication was a problem in this place. Yeah, just going on, we have a problem that we use a couple of softwares which are just way too fast for Debian. Debian is really nice as a solid foundation. Every 2 years an update is nice. Annual would be nice, but wouldn't solve this problem either. Grafana, for example, has I've seen 2 major releases now since the bookworm freeze. Netbox is upgrading every other week. It feels like every week. And most of these updates are not bug fix only, but usually nice features as well. So it's always a bit risky, everything there. SaltStack is a different beast. It's packaged in Debian. It's relatively old in Debian, obviously, because bookworm freeze is 1.5 years almost, or a bit more than a year. And now they made this weird decision to use this 1-year layout. I'm not sure if how this will be patched out of Debian, or maybe the package will just be dropped, and others. There are just too many packages nowadays which are very agile and release often, and I'm not sure how this will work out because I don't want to install everything from Snap, Flatpak, or whatsoever, because at some point it will just bite you because they are not compatible at the kernel level anymore. That's basically almost all. Some specific wish list, because I'm doing some backporting myself, which is not available in whatever Bullseye or Bookworm backports. Why do we have hard dependencies on deb helper versions? I have always to edit the same things over and over again. Some successors to Russ Albury's backport script would be nice to have. It's not hard, it's just a nuisance. With ZFS binary packages, ideally I would like to have them internally, but I have no idea how to build them and how to keep them somehow on track with at least AMD64 kernels and OpenZFS combinations internally. I'd like to invite some guesswork help here for me. maybe also what Thomas was talking about, some cleanup for bugs Debian.org. Just a tick mark to automatically hide ancient bugs. I was looking at some bug reports lately, and there was bug number 200,000 something from 2004, which is probably not relevant anymore, but still listed as one of the many, many bugs. Full text search across all bugs would be nice, which would somehow give relevant results. UDD, I'm not even sure what the abbreviation stands for. I've seen it. It seems to be aimed as developers, which are just have a large number of tick boxes where you can tailor your results. But for me, it wasn't, as a user, completely not usable. That's, in principle, thank you for having the large project and keeping it going, because just my job depends on it. I could obviously use other Linux distros, but I'm just way happier with Debian. Don't try to make everyone happy, but maybe start with 90%, then edge your way up. And on my part, at least, I'll try to get the Max Planck Society's funding to at least get some funding to Frisian or whatever the pronunciation is. I've tried now for 5 years and so far still stuck in our internal bureaucracy because we still have, most of our computers are still on Buster, and yeah, we are not really fast in upgrading. So I'm not sure if we still aim for Bookworm or if we should just wait for Trixie nowadays. But we'll see. That's all.
Thank you, Carsten. I think we have to move the questions to the break again. You can take them outside or inside. And we'll be back in 8 minutes with Hanno on DKIM and his latest findings. See you soon.